Welcome to another episode. In this one, we are going to begin an overall discussion of data analysis. Now, data analysis is a broad term that encompasses many different aspects, everything from descriptive analysis to exploration to predictive and prescriptive. And in each one of those areas, there's many different techniques that are used: deep learning, AI, machine learning, regression. All manner of different techniques can be applied to any or all of these. We are going to be focusing, though, on the first big idea relative to data analysis, and that is the notion of data reduction. Now, data reduction is the idea of reducing data into something that is manageable. If you talk to most people, particularly if they're in the analytics field, or if they think they might want to use analytics for some purpose, you'll ask them, how much of the data do you want? And they'll say, oh, I want all the data. But do they really? And do we really? Let me give you an example. Suppose we have a patient and we have been measuring their systolic blood pressure over a number of days. Now, this particular patient, we've been measuring their blood pressure once a day, same time every day, and we've been doing it for over a year, 380 days. And we're interested to know, is this person's blood pressure in the healthy range? That's the question that we have. So that's the question that we're trying to answer: is their blood pressure in the healthy range? Well, here's the data. Healthy range for systolic blood pressure is between 90 and 120 for adult males. This is the blood pressure for an adult male, measured every day at the same time every day for 380 days. We have 380 data points. So as we look at this, is this patient's blood pressure in the healthy range? Is it too low? Is it too high? I'll give you a moment to look at this. Feel free to even pause the video and look at it. We have all of the data, but if you are looking at it, my guess is you are already trying to categorize, summarize, or reduce this data into something you can get your head around. You may be jotting down little notes to yourself. You might be looking at it and thinking, well, the first column, perhaps there's an average temperature or a systolic blood pressure that I can look at, and so on. Now, however, if I were to take the average or the mean of all of these numbers, all 380 observations, and I were to tell you their average systolic blood pressure is 114, you can probably answer the question instantaneously, immediately. Is this patient's blood pressure too high, too low, or in the healthy range? And we can immediately say that for the most part, it's in the healthy range. And this is the power of data reduction. Data reduction allows us to take 380 numbers, which we can't really get our head around, and we can't really understand at a glance, and it reduces it down to one number. In this case, the average, 114. Now, you may be saying, well, yes, but what about extreme values and outliers? And we know every day it's not 114. And that is true. Whenever we reduce data, we are necessarily losing some detail. But the entire goal of predictive analytics and analysis in general, actually, is to try to reduce the data as much as possible while retaining as much of the information or value as possible. So in this case, as I say, I've given you the average of the systolic blood pressure as being 114, and we're able to glean a remarkable amount of information. We've gone from 380 numbers to one number. But we have to very carefully choose what that one number should be. For example, if I told you that, well, the very first observation is 120, I've also gone from 380 observations or pieces of data to just one, but you really haven't gained much insight. However, by giving you the average or the mean, we immediately know quite a lot about the typical value for this systolic blood pressure. Now, why is this? Well, the answer is um, that human beings are really, really bad at subsidizing. And typically, you can really only do four or so without error. That is to say, if a human being looks at four objects, you can distinguish that there are four objects without having to count. On the other hand, if we start to show a typical human being objects that are, maybe five or six or seven objects, and you glance at it and you try to estimate how many there are there, you will probably have an error of about one. If I showed you 50, you'll be about plus or minus 10 observations. Again, any number greater than that, you need to start counting. And it's the same when you're looking at individual numbers like this and trying to get typical values and get an understanding of it. Anything more than about four, and you're going to start making errors. It's just the way human beings are hardwired. And therefore, data reduction is a critical component and portion of data analysis, which helps us understand and get our hands around what data is actually telling us. If we go back up to this previous chart, what you'll see is we've got descriptive analysis, we've got exploratory, we've got predictive and prescriptive. And as I've said, within each one of those, there can be deep learning, there can be machine learning, there can be all manner of tools that we could use. But for now, we're going to talk about descriptive analysis. And in subsequent videos, I will go into detail about some of the tools at our disposal to do that. Descriptive analysis really comprises about 90% of the analysis that gets done everywhere across the world every day. About 90% of it is just descriptive. And descriptive analysis just seeks to summarize and organize that data so they can be easily understood. But there's no interpretation and there's no commentary. An example would be a census. When we take the census, we collect data from all of the people in Canada at a specific time, and then Statistics Canada will just report their findings. How many people under the age of 18? How many people with an income above $100,000 a year Canadian? You see, we are just describing what happened. We're not offering any commentary. We're not saying, is that low? Is that high? Is that unusual? It is, strictly speaking, just the facts. Another example might be if you look at the reports of yesterday's weather, not a forecast of tomorrow's weather or even weather for later today, but yesterday's weather. It will give you the average temperature. Where I'm living right now, the average temperature was 22.3 degrees Celsius. Is that high? Is that low? You have no way of knowing. All I've given is just a number. All I've given is just a description without any commentary of what the average temperature was where I am living yesterday. So that's the idea with descriptive analysis. And this really does account for probably 90% of the data analysis that occurs on any given day is just descriptive analysis. And it's important. Now, sometimes descriptive analysis is the final step in a process. Control charts, if you're doing a census, if you're surveying customer attitudes, and so on. So a lot of value can be gleaned from it. Think about the census. The reason the government issues censuses, or censi, I suppose, is the plural of that, is so they can know how to plan public services. Where do they need to build roads? Perhaps they may need to think about new schools in certain areas based on demographics and so on. Descriptive analysis is also a very necessary first step in any analytical procedure. Before we get into other things like exploratory or trying to make predictions and those sorts of things, we summarize the data and we simplify it. It helps us understand the features of the data that we are looking at. It can help us double check the accuracy, the reliability of the data that we're dealing with. And it can also prompt important questions for us to ask. Does the range of data make sense? Are there negative values where there shouldn't be any? For example, in the previous slides, when I was showing systolic blood pressure, if we saw a systolic blood pressure of negative 120, clearly something is strange there. So even doing descriptive analysis can give can serve an audit function. Do these summaries make sense? And it can also prompt other questions that might come to mind, things that we may not have thought of, but that we are interested in. So again, in our previous example, 114, we might be asking, well, has that blood pressure gone up or down over time? Those are interesting questions that may have some serious and significant health consequences. Well, that is a quick overview of the idea of descriptive analysis as well as data reduction. Again, the goal in data reduction is to reduce the data as much as possible and minimize the amount of information or insight that we have from it as much as possible. Over subsequent videos, I will start showing you some of the tools that we have at our disposal to do descriptive analysis and some of the ways that we have at our disposal to reduce that data and help us glean understanding from a mass of data. So hopefully this has been helpful, and hopefully you'll join me in the next video.